Alright, so today we'll be doing two specific problems. So, problem A, we'll be proving that f of x equals sine x is uniformly continuous. And the second problem we'll be solving today is true or false the integral from 0 to pi over 2 of f of sine of x dx is equal to the integral from 0 to pi over 2 of f of cosine x dx. Alright, so let's attack A first. So what does it mean to be uniformly continuous? Well, the Wikipedia page has a nice illustration about uniform continuity where they simply drag a box with dimensions epsilon and delta that's centered at a point in the function. And you want the entire function locally to be within that rectangle that's centered at one of the points on the function that's being slowly dragged around. And you want to make sure that every single point in the vicinity of this thing is kept inside this rectangle. So, for example, if we had a function that was like this that suddenly spiked like that, then there would be this portion outside. But don't worry, we can still find a different rectangle that encompasses the whole thing. And all that has to happen is that the dimensions of this rectangle have to stay fixed. But let's be a lot more precise. If two x coordinates, b and a, are less than epsilon apart, if that implies that f of b minus f of a, this would be delta, is less than epsilon, if there is some delta such that this implies that, then we can call the function uniform continuous. And of course, this has to be greater than 0. Alright, great. So, now, how do we prove this? Well, we know that sine of b minus sine of a is actually equal to 2 times sine of b minus a over 2 cosine b plus a over 2. But here's the thing. The absolute value of sine of b minus a over 2 is always less than or equal to 1. Meanwhile, the absolute value of cosine b plus a over 2 is also always less than or equal to 1. Meaning that multiplying 1 and 1 together and adding in this 2, we get that 2 times sine b minus a over 2 times cosine b minus b plus a over 2 has a maximum possible value of 2, which means that if our delta is greater than 2, doesn't matter what epsilon is, this is always going to work. And you can actually intuitively visualize this. How? Well, think about it. If we have that rectangle, if we have that rectangle, like the rectangle right over here, if delta is greater than 2, then that means, 2 is the range of the function. It's the total difference between its maximum and its minimum, which means that no matter what its epsilon is, if we draw that delta to be greater than 2, then there's absolutely, oh my goodness, did I actually swap them out? then there's absolutely no possible way, no matter where we drag this, for the function to fall outside of its borders. Alright, so we've just proved that f of x equals sine x is uniform continuous. Now, let's prove if this is true or false. So it should be pretty obvious to the naked eye that it's false, but we have to actually show that. So the first function, integral from 0 to pi over 2 of sine of x dx, is actually equal to the integral from 0 to pi over 2 of cosine x dx. If you don't believe me, I mean, you can see it intuitively. Sine x from 0 to pi over 2 is this, and cosine x from 0 to pi over 2 is this, so they're basically swapped. But to actually rigorously show that, the integral of sine is negative cosine. So I'll just put that negative outside. And, of course, the integral of cosine is sine. So cosine of pi over 2 is equal to 0, and cosine of 0 is equal to 1. Meanwhile, sine of pi over 2 is equal to 1. Sine of 0 is 0. So we have 1 is equal to 1. Alright, great. So we've shown that f of x equals x does work. So is this actually true? No. For proof of that, stupid eraser. For proof of that, let's use f of x equals x squared. That will mean that we're taking the integral from 0 to pi over 2 of sine squared x dx is equal to the integral from 0 to pi over 2 of cosine squared x dx. Now, you probably realize that cosine squared x is 1 minus sine squared x. So, what does that mean? That means that if we take the sine squared x part of this integral and move it over here, we get 2 times the integral from 0 to pi over 2 of sine squared x dx is equal to the integral from 0 to pi over 2 of 1 dx. Yeah. So we get pi over 2 over here, and what do we get on this side? Well, this is actually an integration by parts problem. So dividing both sides by 2, we get pi over 4, and this is 0 pi over 2 sine x times sine x dx. So doing integration by parts, we get that this is equal to, well, doesn't really matter which one we pick for u or dv, but we get sine x times the integral of sine x is negative cos x minus the integral of minus cos x times the derivative of sine x is positive cos x dx. So we get minus sine cos plus the integral of cos squared. But then realize that this is once again 1 minus sine squared x. So we just get minus sine x cosine x plus x minus the integral of sine squared x dx. And of course, this is already equal to the integral of sine squared x dx. So we bring this all the way over here to get 2 times the integral of sine squared x dx is equal to negative sine x cos x plus x. So, what do we get over here? Well, now that just means that our function is negative a half x minus, sine x cosine x minus x. Now, taking the range of that from 0 to pi over 2, what do we get? Minus 1/2 times, well, what's sine of pi over 2? That's equal to 1. What's cosine of pi over 2? That's equal to 0 minus pi over 2 minus, well, let's see. Well, if we plug in 0, this is 0 and this is 0. So I don't think it really, that's equal to pi over 4.